Hello, everybody. This is Mr. Alberts. I think we should start by just kind of acknowledging how weird this is, that we're not in school, and we will likely not be back for at least the foreseeable future. But we're going to try to move forward, mostly because I've been telling you guys how hard the circles unit is, and if we don't move forward, then you'll never see it, and you'll think that I was lying to you all year. So what we're going to do is we're going to do a couple of lessons a week. I'm going to be recording one here because I want to say hi to you guys. Mrs. Reap is doing the same thing with her class. But moving forward, we might divide up the work. So you might see a lesson from her, and her class might see a lesson from me, vice versa, something like that. But the idea is we're going to go through some notes. I got rid of my guided notes. I'm going to try to cut down as many diagrams as I can because I don't want to expect you to have to print anything. So if you have a blank piece of paper or lined paper, you should be able to follow along with me and get some pretty good notes. You should also be able to pause the video, rewind the video, so it should be very helpful in that respect. And that's pretty much it. Hopefully I see you guys on Fridays for the office hours. If only to stop in and say hi. I miss you guys. I'm just sitting home with my dogs all the time. So if you hear people barking in the background, that's either Theta or Maslow. Maybe they'll make an appearance in one of these videos at some point. But so pause, go get some paper. We're going to try to get some stuff done. If I had more answers for you as far as what the future looks like, I would tell you, but I'm almost as in the dark as you guys are. The plan for now is to move forward with Chapter 8, and a little bit further than that. We probably will not be able to get to some of the area things, but largely you're going to need that for MCAS, and you have a formula sheet. There's a lot of things that you guys should be fine on. You guys have been taking my tests all year. Once you look at the MCAS and compare those geometry questions to the ones that I make up, you'll see there's not really a comparison. You guys are going to be fine. The goal is to cover as many hard things as we can, so you guys can, first of all, see the material to begin with, but also these are some strange geometry or more complicated geometry things that could show up on the SATs. So anyway, that's enough of the introduction. Hopefully the ones in the future can be infinitely shorter than that. Let's start with Chapter 8. We're basically done with Chapter 7. We did all the stuff. We did all the review. There's not really a way to give you a test sitting at your house. So we're going to start these videos now. Fresh, new chapter, new material. And we're going to be talking about angle measures and polygons. So there's only a few things that we really need to go over for these notes. The first thing is a definition that we're going to use for some stuff that we're going to be doing in just a moment. And that is the idea of a diagonal. So a diagonal is just a line segment drawn inside of a polygon. So a diagonal of a polygon is a line segment, I tried very hard to write legibly for you guys, is a line segment joining two non-adjacent vertices. Okay, so the non-adjacent just means not next to each other, clearly. So if I had from point A, B is an adjacent vertex. So obviously the line segment containing going from A to B, going to an adjacent vertex, is just a side of the polygon. So if I go kind of clockwise here, A to B, B is adjacent, so this is just a side. C is our first non-adjacent vertex. So if I connect those, okay, that would be a diagonal. D is also non-adjacent, so I can connect those here. Okay. And then E again is an adjacent one. So these two things here, okay, so from A, I can draw AC and AD are both diagonals. Okay, so those are all the diagonals that I can draw from A. You could clearly go back and do the same thing from B or from C, etc. Okay. So I want to know what a diagonal is because the main thing that we need from this section is the idea of the sum of the interior angles of a polygon. Sum of the interior of a polygon. We already know one of these. Okay. So if I make a little list over here, number of sides. Okay, we'll use that for n. Okay, and then this is going to be the sum. I'm leaving a giant gap here on purpose. So leave yourself a gap there and let the anticipation build. Okay, so we have the sum of the interior angles. Okay, so the one that you clearly know already is our smallest polygon, which is just a triangle. Okay, so the sum of the interior angles of a triangle we know to be 180 degrees. Okay, and so we're going to actually use that to kind of build up to our first theorem of this chapter. Because if I go to 4, a lot of you guys are probably just like, oh, that's 360. Like, a lot of you just kind of know that these are 360. But the sum of the interior angles of any quadrilateral, okay, we can actually derive that by using this first thing, by drawing in a diagonal. So if I go hit through here and I draw in one of my diagonals, okay, what do I see? I see that that actually creates now several triangles. So I can make kind of a new column here. This would be the number of triangles that I can make by drawing in diagonals. So if I draw in a diagonal in a quadrilateral, that's going to give me 2 triangles. Okay. And so the sum of the interior angles, if I know one triangle is 180 degrees, then the sum of the interior angles for a quadrilateral is going to be double that because I have 2 triangles. So it's going to be 360 degrees. Okay. And so we can actually kind of continue this pattern. So if I start drawing larger polygons, so if I just kind of draw in a pentagon here, so it's something 5, and I do kind of the same thing, just pick any vertex you want. We have the adjacent vertex, I have non-adjacent, non-adjacent, okay? I can see that by drawing in these diagonals, I now have 3 triangles. So the sum of the interior angles will be whatever 3 times 180 degrees is. I believe this is going to be 540. All right, and you can continue that. This pattern will just keep continuing. And so that leads us into this last part here, which is what if I did just n, so just any size polygon, okay? And so I can look for a kind of pattern here. Clearly a triangle is made up of one triangle. So these are increasing, but the relationship between the number of triangles and the number of sides is that the number of triangles is 2 fewer than the number of sides. So if the number of sides here is n, then this will create n minus 2 triangles. Okay, and you can just draw some arbitrarily large polygon and kind of try that out. This ends up just being because you create a triangle for every time you draw in a vertex, okay, and you cannot draw them to your 2 adjacent vertices, okay. So this gives us now a theorem where I have, the reason why I left this part in, the 2 times 180, the 3 times 180, is so you can see this continuation where it's the number of triangles times 180 degrees, okay? And so this is our theorem. This is the sum of the interior angles of an n-gon, so an n-sided polygon. Okay, and so we're going to utilize that. Now, a kind of corollary to this, okay, is that we're going to use without really using this. Like, I'm not going to draw this out a million times for a quadrilateral. So the fact that you know that the sum of the interior angles of a triangle is 180, you're going to use that for quadrilaterals as well, kind of as a given. So the sum of the interior angles of a quadrilateral is 360 degrees. Okay, so just like how up to this point, if you're saying that the sum of the interior angles of a triangle is 180 degrees, I'm not really asking you to justify that. I'm not going to really ask you to justify the quadrilaterals having a sum of 360 either. Okay, So we'll do one example here. Okay, so I'm going to draw a picture best I can. Okay, and again, you don't have to make these look perfect. Just do your best. All right, so this is a question where I'm going to ask you to find the measure of angle T. Okay, so I'm not going to really kind of like our normal class structure where I'll do an example and then you can do some practice and then we go over them, etc. All the examples can just be practice problems. So what I would suggest you do here is just pause it. And then you can just try this on your own real quick. And then you can just come back and play the video again. If you're not comfortable at this point in the notes on something, don't pause it and just take it as an example, okay? So every example I do, before I get started, you can just pause it and take it as a practice problem. And if you're not feeling confident, don't do the practice problem. Just watch it straight through as an example, okay? So where we're going to start here, we're going to use this theorem that we have. First thing we have to figure out is how big of a shape we have. This is a pentagon. So because we have a pentagon, our number of sides is 5. So the sum of these interior angles, is number of sides minus 2 times 180. And this ends up being 540 degrees. Okay. We can also kind of cheat. Look up here. We already did pentagon in our example before. All right. So now I have this. I can set up an equation. The fact that I have these congruent tick marks here, I know that the measure of angle T is equal to the measure of angle S, so I can use kind of the same variable as those. And then we just set up an equation. So the angle measurements are 93, 156, 85, and I have two x's, and they add up to 540 degrees. All right. So we can solve this. These three things combined, they add to 334. And then we get to subtract the 334 from both sides. And I believe that gives us 206. And we divide those in half, we get x equals 103. And we know by now, hopefully, although maybe not, it's been a little bit of a break, maybe we've gotten a little rusty, we know that's not our answer because that's not what was being asked. Okay, so the measure of angle T is the question. So the measure of angle T is our answer. So the measure of angle T is going to be 103 degrees. Okay, super. All right, so those are the interior angles. We're going to move on. We're going to do one more part here with exterior angles. It's the same thing. So this is a little bit of a harder one to prove, but it's a much easier equation. So we're going to look at the sum of the exterior angles of a polygon. Okay, so the sum of the exterior angles of a polygon is always 360 degrees. That's it. Doesn't matter how big it is. Okay, so remember exterior angles. See, I could have a triangle here. I could have some sort of a quadrilateral here. I have some sort of a pentagon. Okay, and remember our exterior angles come from extending those side lengths. Okay, so the exterior angles are here, here, and here. Okay, and again, these don't have to be the same measurement unless the shape itself is regular. So you have these exterior angles. So these three angles add up to 360. These four angles here add up to 360. And these 5 angles created here, just go around and make a little pinwheel. And these 5 angles here add up to 360. Okay, so it actually doesn't matter at all how many sides there are. The sum of the exterior angles will always be 360. that's basically it. That's the theorem. There's actually a great kind of GIF for this, so I'll try to find it and share it with you online. There is a proof for this, which I love proving things. Okay, it's actually kind of a fun little algebraic proof. Okay, so the only thing we need for this proof is that we are given an n-gon, which just means we have a shape with n sides. Okay, I'm going to draw it so this clearly has a defined number of sides, but just pretend, this is more abstract than that. You don't know exactly how many there are. Now, what this proof assumes, okay, well, we don't really have to assume it. You just kind of follow along here, is if there's an n-gon, there's n sides, which means that it has n vertices here, okay? And what I want to do is I want to add up all of my interior angles and all of my exterior angles. So I'm going to make an equation here. The sum of the interior angles plus all of the exterior angles. And what you see is that if I have, in one case here, I have this interior angle, and if I combine that with the exterior angle, okay, they'll add up to 180 because that makes a straight line. And if you do that at each intersection, you'll see that all of those end up being 180 degrees. So if this is an n-gon, I'm going to have n vertices here, and at each vertex, there's going to be 180 degrees total between the interior angle and the exterior angle. Okay? And we actually know what this is. This is our theorem on the first page. Okay? And so the sum of the interior angles was the number of sides minus 2 times 180 degrees. So I can just substitute that. So that plus the sum of the exterior angles is equal to n times 180. I'm just going to call that 180n now. And if I go back and I distribute here, I get 180n minus 360 plus, this is the sum of the exterior angles, and this equals 180n. So if we now eliminate these things, I can subtract 180n on both sides. Okay. And I can add 360 to both sides. Everything cancels except we see that the sum of the exterior angles of a n-gon is 360 degrees. So regardless of how many sides there are, the sum is always going to be 360 degrees. Okay? So I'll end today with just one more example that uses kind of both of these. Okay? It'll be a question that looks like we want to use our first theorem. So I'm not going to draw the trampoline on this. Okay? Because it's not important to necessarily have a diagram. Feel free to draw it if you want. This is a question about a trampoline. So a trampoline is in the shape of a regular dodecagon. All right. So a trampoline is in the shape of a regular dodecagon. We want to find the measure of a single interior angle. Okay. So there's a couple ways we can do this. I'll just label this way. Way one, okay, this is kind of like the direct way, is that I see the word interior angle, so I know to myself, well, I know that theorem, that the sum of the interior angles is n minus 2 times 180. So I'm going to do that. So I have a dodecagon here that tells me that I have 12 sides. So the sum of the interior angles is going to be n minus 2 times 180. So this is 10 times 180. This is 1,800. 1800 degrees. So that is the sum of all of the interior angles. So therefore, just one interior angle, okay, is going to have a measurement of the sum of all the angles. So it's 1800 degrees for all 12 angles. So a single angle, I just divide that by 12, and this is 150 degrees. Okay, so that turns out it's not too bad. There's actually another way to do it. Not that this was super complicated, but it might be a slower way than a way that you could think the other way around. And so even though this doesn't say anything about exterior angles, remember, we're always trying to make our lives easy. And this formula is just that they always add up to 360. Always. So if you can use exterior angles, it is usually probably going to be a faster or easier calculation. So in this case, just the measure of one exterior angle is going to be 360 degrees divided by 12, because I have a dodecagon, so I have 12 interior angles. That means I have 12 exterior angles. So if you just divide 360 degrees by 12, you can see that all of the exterior angles are 30 degrees. And so what that means for our shape, right, is if you had extended the sides and you have an exterior angle of 30 degrees, then what is your interior angle going to be? So what that means then is that the measure of an interior is 180 minus 30, because they form a straight line. They're supplements. So the measure of one interior angle is going to be 150 degrees. So you get the same thing. Okay. That's it for the new material. What we'll do is I'll also post some practice problems for you to do. I might end up going back and posting the answer key as well. But by all means, when the stuff gets more complicated, please go back and rewatch these videos. I don't think this stuff, being the first day of the unit, is too bad. So go on, try the practice. I'll show you how to submit it on Google Classroom. And then hopefully I'll see you on Friday if you guys have any questions. Take care.